We know that time period is 1 divided by frequency. The more often something completes a circular path, the less time it takes, and vice versa. We also know that the velocity of an object undergoing circular motion is the same as 2 pi times the radius of the circle and the frequency. That means that the velocity equals 2 pi times radius divided by time period. The faster an object orbits a circle, the less time it takes to do so, as long as the radius of the circle doesn't change. From our previous podcast, we know that the velocity needed to escape a gravitational field at a given distance from the centre of this field is the square root of capital G, capital M over r. This escape velocity is a circular velocity, and so can be expressed as 2 pi r over t. As we discussed before, we can rearrange this equation to show us that from square root gm over r equaling 2 pi r over t, we can get gm over 4 pi squared is equal to r cubed divided by t squared. G, m and pi are all constants, so we can see that r cubed over t squared is also a constant. So either r equals the cube root of t squared, gm divided by 4 pi squared, or t equals the square root of r cubed times 4 pi squared divided by gm. We can see that the distance from the centre of a gravitational field and the time period it takes to go around this field at escape velocity are linked by a constant. This means that for a given distance from the centre of the field, you have a fixed time period. If you want a satellite to orbit the Earth in a fixed time period, you must place it at a set distance from the centre of the Earth.